5E, using congruent triangles. CPCTC, so this is a rule that we can use, and it says that corresponding parts of congruent triangles are congruent. So that's what the CPCTC stands for. The first C is for corresponding. And then parts of congruent triangles are congruent. It's kind of a mouthful, but that's why we often use the abbreviation CPCTC. So, if you've got two congruent triangles like triangle ABC and DEF, well, A would match up, angle A would match up with angle D, so those would be corresponding parts of those two triangles because they're both in the first slot. So those would have to be congruent angles, and B matches up with angle E, angle C matches up with angle F. And you can do the same thing with the sides. AB is the first, those are the first two letters here. So those are going to correspond with the segment from the first two letters in the other one. So AB would be congruent to DE, they'd be corresponding pieces. BC, that's the second and third letters, so EF. And then CA, that's the third letter followed by the first letter, so FD, that would correspond to segment FD, okay? So here we're going to show that angle A and angle C are congruent. They're not marked as congruent in this diagram. So what I want to do first, in order to use CPCTC, you have to have congruent triangles. I don't have that yet, so I'm going to first show that the triangles are congruent, and then if the triangles are congruent, then angle A would have to be congruent to angle C because they'd be corresponding parts. Okay, so looking at what I've got this one set of sides, and I've got the second set of sides. SS, that's not enough, so I need something else. And I'm noticing, hey, there's this shared segment in the middle. So I can say that this segment is congruent to itself. So yeah, I'll say that's congruent to itself, and that would be the reflexive property of congruence. Anything is congruent to itself. Okay, and now I can say the two triangles are congruent, so I'll call the triangle on the left triangle ABD. And then let's see. The second triangle C would match up with A, and B would match up with itself, and so would D. Okay, and I'm using SSS, right? This is the side triangle congruency theorem. Okay, and now that I've got those triangles congruent, well, now that I can say, hey, these are corresponding pieces of those triangles, so they have to be congruent by CPCTC. So you have to get the triangles congruent first before you use CPCTC. Okay, so that's CPCTC in action. All right, let's take a look at a proof here. So we've got this two-column proof. It says that angle E and angle H are congruent. That's already marked in the diagram. It also says G is the midpoint of DF. So here's DF, and G is the midpoint. So what that is actually telling me is that these two segments have to be congruent, okay? So that's going to be my next statement. So my first reason for that first statement, that's the given info, okay? But then I'm going to use the G is the midpoint to say, okay, well then DG is congruent to GF. Because that's what midpoint means. It means it's going to cut a segment into congruent segments. So this is definition of midpoint. Okay. Now I'm trying to show that ultimately, I didn't really read what I'm trying to do at the end. I'm trying to show that EF and HD, so that's this segment and this segment, I want to show that those are congruent. So what I want to have first is the triangles congruent. So I've got the set of angles that was given. I've got these. I've got the one set of sides that I used I used the midpoint to get those sets of sides. That's still not enough. I need something else. And I'm noticing, oh, I've got vertical angles here, right? these two angles would have to be congruent because they're vertical angles. They're opposite each other at that intersection. So I'll call the angle in the bottom triangle angle DGH. Angle DGH. You can't just call it angle G because it's not clear what angle G would mean in this diagram. Okay, and then the angle in the top triangle with the two dashes would be EGF. Okay, and that was the vertical angles theorem. Okay, all right, so now I have enough to say that the triangles are congruent. It would be by AAS, right? Two angles and a non-included side in both triangles. So let's see, the bottom triangle, I'll call that triangle DGH. And I have to be careful when I make my congruence statement here. I can use the letters in whatever order I want in the first triangle, but then I got to make sure I get the angle that matches up with D, which it's the non-marked one in the top triangle, which would be F, right? And then G matches up with itself, and H is going to match up with E. Okay, so those triangles are congruent by AAS. Angle, angle, side, triangle congruency theorem, or just AAS for short. Okay, now that I've got the triangles complete, well, now I can finish the proof and I can say, hey, these two sides are corresponding sides of those congruent triangles, so they must be congruent to each other. So now I'm going to say, okay, EF is congruent to HD, and this would be by CPCTC. Okay, and we finished the proof there. Okay, all right, let's try another one. So my first reason is going to be given. I'm not even reading this stuff really, but that's always the first given. The reason is always, first reason is always given. I can see that is that same info from up above. Okay, so let's see. It tells us we've got these sides are congruent. That's already marked in the diagram. We also have some perpendicular segments, so that's going to give me some right angles. Okay, but let me think what I'm trying to prove first. I'm trying to prove that these two angles are congruent. They're not marked congruent, so what I want to do is get the triangles congruent, then they would be corresponding parts of those congruent triangles. So I'll be able to finish this proof with CPCTC once I get the triangles congruent. Okay, so I want to do something with those perpendicular segments, this and this. So this is telling me NK, that's this one, is going to be perpendicular to NP. That means I've got a right angle there, okay? And then NK is also perpendicular to LK. That means I've got a right angle right there, okay? So now I can say angle N and angle K are right angles. I'm going to put those in the same step. You could split them up if you wanted. But I'm putting them in the same step because I'm going to use the same justification. I'm going to use the definition of perpendicular. Okay, I know perpendicular means they form a right angle, and it told me those segments were perpendicular. So this is definition of perpendicular to get those right angles. Okay, now I'm thinking, okay, still got, I can show that those right angles are congruent to each other. So let's go ahead and do that. So now I'm going to say, okay, this angle is congruent to that one, because all right angles are congruent. So I'll say angle N is congruent to angle K. It's the right angles congruence theorem. Or for me, you could just say all right angles are congruent. That would be fine too, okay? So I've got one set of sides, one set of angles, still need something else. And I can use the vertical angles here again, right? I've got these vertical angles that are congruent. So I'll call the one on the bottom angle LMK. And that will be congruent to angle PMN. That's that one from the top triangle. That's the vertical angles theorem. Okay, now I've got enough to show that the triangles are congruent. It would be by ASA this time, two angles and an included side. So I'll say the bottom triangle LMK is congruent to triangle PMN. And make sure you get the corresponding pieces in the same, letters in the same positions I do here. This is ASA, angle side angle triangle congruency theorem, okay? And now finally I can finish the proof. Now I can say, okay, now that those triangles are congruent, then angle L is congruent to angle P. This would be by CPCTC, okay? I think that's the end of the section, and I'll see you next time.